Hello again. For the last couple of lessons, we've been talking about how to model linear behavior. So we're going to move on to the next family of functions, which is quadratic functions, and how to model those type of real-world situations. So let's get started. We have an example. A man is being shot out of a cannon, and his height in feet is measured for every second. So those are his heights for every second for the first 6 seconds. All right, first of all, let's figure out whether this is a quadratic relationship before we find a quadratic model for it. So to do that, we are going to look at second differences. Remember, that's how we tell if a relationship is quadratic or not. So what I do is I find the differences between all the y values the way they are in this table. And if those differences are close to each other, then this relationship is linear. So let's do that. To get from 0 to 82, that's a difference of 82. To get from 82 to 133, that's a difference of 51. And I calculate all of the changes like that. And as you can see, they're not very, very close to each other. So this is not a linear relationship, but remember, that's not what I wanted anyways. I wanted a quadratic relationship. So now let's look at the difference between these red numbers that I've written down. And hopefully those will be closer together. To get from 82 to 51, that's a change of negative 31. To get from 51 to 19, that's a change of negative 32. And the rest of the differences can be calculated in the same way. And as you can see, these are closer together. So it looks like this can be modeled with a quadratic function. All right, so let's get started doing that. We're going to do a quadratic regression, and there are many tools on many technological devices that will allow you to do this. I'm not going to be picky as to which one you use, but we will go over a couple in class. So we're going to use technology, and we're going to enter the data into a table. Now, I've used an Excel spreadsheet to do that. It's the same data that we saw before, and now I can plot those points on a graph, and there's my graph right there. And as you can see, it looks a lot like a parabola. It's opening down, and I can kind of see where the vertex is going to be. So if I use a regression tool, I can plot a parabola that touches those points or gets as close as it can to as many of those points as possible. And if you look at the graph, they've actually tried to come up with an equation for that parabola. It's got a lot of decimal points, but that is the equation that we are going to use to model this data. All right, it is y equals negative 15.905x squared plus 98.286x minus 0.0952. All right, now if you look at the r squared value, that tells me how good of a fit it is. So anything that's close to 1 is going to be a very good fit. And 0.99997 is very close to 1, so it is a very good fit for the data that we've got. All right, so now let's interpret this. Let's figure out maybe what his maximum height was, or we can figure out what his maximum height might have been. So to do that, we find the vertex. And since our equation is in standard form, we are going to figure out the x-coordinate of the vertex by doing negative b over 2a. Okay, and remember, our b was 98.286, and our a was negative 15.905. And so if I plug those into negative b over 2a, I get 3.09 seconds. So that's when he reached his maximum height. Now let's figure out what the maximum height actually was. I'm going to plug it into the original equation that was given to me by Microsoft Excel. There's my equation with 3.09 plugged in, and what I get is 151.75 feet. All right, so what that means is he reached his maximum height of 151.75 feet. All right, so that is how you model quadratic data. We will go over more examples in class. If you have any questions, please let me know, and I will see you tomorrow.